I'm Laura Ligaitis. I am a software engineer in training working for Raptor Integration. Porcupine is taking lumber and trees coming out of the forest, and they're processing them into boards for decking, trim, fencing, and things like that. So where Raptor comes into play is at any given stage, we collect the raw data, and then we can apply any type of logic that we need to be able to get the best value out of any piece. So at the gang here at Porcupine, we are scanning cants that are coming in from an upstream process, and when they come out the back end, they go into boards that are either sent off to an edger or straight to the trimmer. It has a break in the belt where we have the scan frame. We put 4 sensors, 1 on each corner, and that allowed us to get 360 degrees of view on every cant at a high resolution to create the best model without missing any defect that's on the bottom or the sides or the top. So on the flitch scanner Q, the flitches are being scanned in transversely. From that transverse scan, we are getting geometric data, trachea data, and vision data. So the vision component will allow us to get that pixel-based image, ties in nicely on top of the mesh that is created by that geometric profile of the piece to combine it all together. And then we go about being able to produce the best edge decision, and we send it through an edger. Here at Porcupine, we have a board scanner, and so we are taking the geometric profile of all of the pieces that are being scanned through transversely, and then we are able to give them the best trim decision. In this case, we are able to use the geometric data to calculate anything like wane or thickness and width thresholds. It allows us to detect rot and the deviations in the thickness in the middle of the pieces or along the edges. Further, getting such a high resolution data allows us to do many quality controls alarms. We can detect if there's something like wedge going on at the downstream process that might be indicative of something upstream that needs to be tuned.
We have to be able to always pay the most or the best to be able to get the log, because there's many others that want the log around us. So automation is very key for us to be able to extract that value. We have gone down this path of adopting technology to help us with grading out materials that are what I like to call waste of time process. Things that don't need to be handled a second time, I like to get rid of and put them into a byproduct as quick as I can so that it doesn't cost me more money to handle something that's going to make a chip at the end of the day. I would say that we have increased our output of good grade material by more than 15%. The sky is the limit, and it's not just this type of scanning automation, it's robotics, it's all that kind of stuff, right? When it's viable economically to me as a small producer, it's something I want to jump into.